Welcome to today's deep dive. We are jumping right into an amazing source deck today. It's called TD0024 Technical Discussions.
Yeah, and our mission for you today is to really distill the strategic vocabulary of a veteran consultant into, actionable mental models.
Exactly. We want to help you navigate those really complex technical meetings and client interactions with absolute authority.
Right, because these terms, they get thrown around in boardrooms so often they kind of start to lose their meaning.
Oh, for sure.
But a seasoned consultant uses them deliberately, like not as corporate buzzwords, but as actual diagnostic tools to control a narrative.
And reframe those systemic failures, right?
Mhm.
So let's start with the foundational reality of engineering and business, which is the trade-off.
Ah, yes, the trade-off.
People always love that master's understanding analogy of the balancing scale. You add weight to one side to gain a specific performance metric, and you inevitably concede another.
You do, yeah.
But honestly, like, a scale feels a bit passive for what is actually happening on a mechanical level, don't you think?
It really does. I mean, a much better way to view a trade-off is through sheer physical causality.
Okay, how so?
Well, take the source's example of choosing between higher torque and shorter bearing life. It's not just some philosophical choice on a spreadsheet.
Right.
Because when you increase torque, you are exponentially increasing radial load and friction.
Oh, wow, so it's a structural thing.
Exactly. The physical materials of the bearing are fatiguing faster at a molecular level. You aren't just tipping a scale.
You're actively paying for power with the lifespan of your materials.
You are.
Which, that brings us to where projects actually fail. Because failing to honestly weigh that mechanical reality, it inevitably sinks you below the surface.
Oh, totally.
And that leads right into the massive hidden cost. The deck uses this classic iceberg analogy for it, right?
Yeah, the unseen maintenance hiding beneath the waterline of, like, a cheap purchase price.
Yes. Let's look at the mechanics of that using the deck's example of buying cheaper seals.
Right, so buying cheaper seals looks like a huge immediate win for the quarterly budget.
Everyone loves saving money up front.
Exactly, but the hidden cost isn't just an eventual oil leak down the road. It is the technical debt you are taking on.
Technical pet, yeah.
Because that cheap seal might cause microabrasions in the housing over time, right? Which eventually leads to a total systemic pressure failure.
Wait, really? Just from the seal?
Just from the seal. You saved a few dollars up front, but you essentially took out a loan with a 25% compounding interest rate payable in future downtime.
Oh, man. So when that downtime starts to actually manifest in real time, how do you communicate it without inciting a total boardroom panic?
Well, that is where the source brings up the red flag.
Ah, the racing analogy. A red flag halts the track to prevent a disaster?
Right, but yelling red flag over, say, a sudden temperature spike during a test run, it serves a very specific psychological purpose in a meeting.
Which is?
It acts as a conversational circuit breaker.
A circuit breaker.
Yeah, because a sudden temperature spike isn't just an interesting data point. If you tell a client your design is failing, they immediately get defensive.
Of course they do.
But by labeling the anomaly a red flag, a consultant externalizes the threat. It safely halts the groupthink.
And it prevents catastrophic results without, assigning blame to the engineers sitting right there in the room?
Exactly.
But we can't just be the bearer of bad news throwing down circuit breakers all day.
Yeah.
If we are pitching a client, how do we frame the ultimate win?
Then you aim for the best of both worlds. And let's be precise here, because this absolutely does not mean a compromise.
Right. A brutal compromise means everyone walks away slightly unhappy.
Exactly. Achieving the best of both worlds means solving mutually exclusive problems simultaneously.
Okay. And the deck highlights a hybrid design as the example here, delivering both high efficiency and low noise.
Right.
Which is tough because mechanically a highly efficient machine usually requires higher RPMs.
Yeah.
And that inherently displaces more air and creates way more noise.
Which is exactly why achieving this requires a fundamental paradigm shift. Not just tweaking existing parts.
Oh, I see.
You have to introduce a completely new mechanism that bypasses the friction causing the noise in the first place.
And when you pull that off, you completely dominate the market.
You do, because you've delivered a hybrid that defies the expected physics.
But even if you design that ultimate hybrid on paper, execution inevitably hits a physical limit, right? The bottleneck.
Yes, the bottleneck.
The deck uses that visual analogy of a bottle's narrow neck restricting the speed of water flow. I will push back on the common definition here, though.
Oh,
Yeah, calling a bottleneck the weakest link in a system feels incredibly misleading to me.
well, you're right, because a bottleneck isn't necessarily broken. It is simply the absolute limit of the system's current capacity.
Right.
In the theory of constraints, you don't just identify the bottleneck. You have to subordinate every single other process to its pace.
Like the source's example of a rigorous quality control process dragging down a production line.
Yes, exactly. If QC is your bottleneck, running your upstream manufacturing equipment faster doesn't help you at all.
It probably hurts you, right?
It absolutely hurts you. You just end up piling up expensive, untested inventory right in front of the QC station.
Wow.
A veteran consultant knows that an hour lost at the bottleneck is an hour lost for the entire system,
But an hour saved at a non-bottleneck.
is an absolute mirage.
That is such a great way to put it. These really aren't just vocabulary words to sprinkle into your next presentation.
No, not at all. They are crucial frameworks for evaluating the physics of your technical projects.
And diagnosing where your systems are actually failing.
Right. They force you to look at the causality behind the problems rather than, just treating the symptoms.
So, to leave you with a final thought to ponder today, if you apply the concept of bottleneck to your own daily workflow or your learning habits, what is the single narrow neck currently restricting your own professional output?
That's a great question.
Are you trying to speed up everything else instead of just honestly addressing that one core constraint? Something to think about. Thanks for joining our deep dive, and we'll see you next time.